Welcome back, everybody. So I'm going to continue on something that scales. So it was the question that you asked earlier, right? About can we store data across multiple regions? I have to wait until we have the quiet. Yes, awesome. So this is a newer technology. So GFS and Bigtable are actually no longer really the latest technologies at Google. Instead of HGFS, they have something bigger called Colossus. And instead of Bigtable, they also have something bigger called Spanner. And so of course, I'm not familiar with this with the same level of depth, but of course, if you have any questions, I can still investigate them. But I can tell you more or less on the very high level how this works. Spanner, like Cassandra, allows you to have primary keys on multiple columns. So in HBase, you remember, it's just the row ID, and that's one unique monolithic key, right? In Spanner, you can have a multi-column primary key, right? So compound row ID if you want. Then something that is also interesting is that when you're responsible for zones in here, they are not contiguous. So we don't have the contiguous regions. We have something called tablets. The tablets are made of fragments. This is a fragment, this is a fragment. So it gives you more flexibility because when you move data around, it's the fragments that are moved around instead of the regions. So it's the fragments. So that gives you a bit more flexibility. Above the tablet, there's the notion of directory. So a directory is a contiguous region, but it is fragmented, and the tablets have multiple fragments. For whom does that make sense? For whom does that not make sense? Okay, more sense for makes sense. That's a good thing. So yes, so that's the two main differences, right? Multiple column primary key, and then we have these partitions that are non-contiguous. But that's the cool part. We can have, there are so many zeros that I have to look at it twice in order to tell you that correctly. Do you agree that's 1 quadrillion? Not 1 trillion. Trillion. We can do quadrillions too. That's trillions of rows, trillions of rows. So that's much more than HBase can handle, right? We scale to the billions. I don't know if you might be able to push HBase to a trillion, but this is literally multiple trillions, tens of trillions, and I think it goes even to the quadrillion potentially, if I correctly remember. So that's huge. And because it's huge, you need something even huger to organize that. And this is, again, a super cool part, because now these data centers or availability zones, they still exist, right? So you still have these clusters with a centralized architecture, but now you have plenty of them all over the planet, and they are connected to one single universe master, the coolest name ever. So, so this is the architecture, and now we are across multiple locations on Earth, right? And potentially multiple regions. Okay, so does that answer your question that you asked earlier? Even though it's a different technology, right, than HGFS, right? Okay. And that means that now you just have not a single data centers, but you're even counting the data centers now. So you have hundreds of data centers that store your data. As you can imagine, only very large companies can do these sort of things. I mean, that's something that costs obviously a lot of money, and millions of machines across all of these data centers. Okay, so that's basically just where I wanted to end, just show you that engineers have taken it already beyond what we saw in HGFS and HBase, and we have even bigger things than this. So here I want to ask you again, you know why I'm asking that. It's your remote control to slow me down or accelerate me. Right, so I know I warned you at the very beginning. Remember when we started the HBase lecture, I warned you, I told you, this is the most complex lecture of the entire semester, right? So I expect it to be slightly biased going to the right, okay? So this is almost as anticipated. But what that tells me still is that first, if you have any questions, even tomorrow, you can come with more questions in tomorrow's lecture. I can re-explain things at your own rhythm. You should read the textbook, which I fixed a few things to accommodate for questions. You can ask questions on the course forum, on the Moodle forum. You can send us direct emails. That works too, to me, to Dalia, to the other TAs. If anything is not clear, just drop us a question. Right? There's also Ethel, the chatbot, but you can also ask us directly, right? We enjoy interacting with you. Okay. And that should also act as feel good for those of you who didn't understand everything. You're not the only one. This is complex, and you can also discuss amongst each other. So the two who understood everything, congratulations. You can try to explain it to other people also. It's a very good exercise to try to teach and explain. That also will improve your understanding. All right. Very good. So I'm going to stop this lecture here. If there's questions tomorrow, I'll take the time to answer more of them. And otherwise, I'll stop the recording here and move over to the next part, which should be a bit easier.